Welcome back to College Hill Farm. Well, today we're going to talk about human-made climate change. Now, I know some of y'all are not going to believe anything I say, and that's your business. I graduated in 1984 from my undergraduate degree, a bachelor's degree in physics and chemistry. And I have been evaluating papers and statistics and things like that, scientific journals, for the last 40 years. 85, 86, 85, 95, 2005, 2015, 2025. All right. 95, 40 years, 40, 4-0. So I've been at this a long time. Sometimes I misspeak. It is so easy to distrust that people fail to see what's true. Now, for those of you that know, I'm a prepper, but I'm not a doomsday prepper. I'm a common sense prepper. I believe in the very first thing you should do is prepare for losing a job. Okay, prepare for getting hurt. Prepare for the power to go out for a week or two. Okay, those are the very first things you should prep for. But the number one thing a prepper needs to be able to do is discern bullcrap when he hears it. He needs to understand what's going on in the world so that he can decide what's the most imminent threat. Now, as a scientist, that doesn't make me better than you. It doesn't make me smarter than you necessarily, but it does make me better read. Okay, I have read more. I understand more about the way the environment works and about the historical facts about the environment. Physics and chemistry get you right to the heart of the way the planet and the universe works. That's the whole philosophy behind physics, is how does the universe work. So let's talk about man-made climate change. Now, let's talk about the things that make the environment change. Carbon dioxide, methane, and some other gases wind up in the atmosphere, SO2, and there's a whole bunch of them. They wind up in the atmosphere, and normally what happens, the sun beams energy down in photons of light, and that energy hits the ground and it warms the ground, it warms the earth. It's converted to photosynthesis, it's converted to solar energy, all right? And it hits here on the planet and it warms, and then any excess bounces back and goes off into space. Well, certain gases will allow it to come in, but it doesn't have enough energy to bounce back out if there's a thick layer of gas above it. This causes something called the greenhouse effect. When you get inside of a greenhouse, all right, it may be 80 degrees outside and you've got the sides raised on the greenhouse, but it's still almost 100 degrees in the greenhouse. It's the same effect that's happening when you get an excess of stuff in the air. In 1900, just at the beginning, just before the Industrial Revolution really kicked into gear, in 1900, the amount of carbon dioxide in the air was 280 parts per million. In other words, it was fairly low. There was human activity, but we weren't putting out that much carbon dioxide, because in the last 100 years, the amount of heat on the earth has risen about 1.2 degrees, maybe up to 1.5 already. but it has risen about 1.2 degrees, and it's a pretty steady climb. And it's almost perfectly aligned with the amount of fossil fuels we've burned in the Industrial Revolution, because it's a straight up. Now, some people say that the Earth is always warmed, but those changes take thousands of years. This has happened in a century, okay? Happened in a century, in 100 years instead of 1,000 years, so, or 10,000 years, all right? We're at the last end of our last ice age. We're at the end, we call it an interglacial period. And the Earth has just taken off warming in the last 100 years. And that's because we're burning coal and oil and gas and all that stuff, putting that CO2 in the atmosphere. Then we do something called an isotopic analysis. When you look at the type of carbon, there are lots of carbons emitted. The natural way that the Earth emits carbons and SO2s and methanes is when we have, it's called isotropic carbon. In other words, it comes from volcanoes, it comes from other natural sources, okay? Other natural sources. But CO2 in the atmosphere is directly related, that carbon is directly related to the burning of fossil fuels. It's all from fossil fuels. And there are hundreds of research papers since the 50s that have pointed to the increase. Now, when scientists look at a problem, they create models, okay? They create models where they can put in the model what this is and what that is and what that is, and they test their hypothesis or their climate model to see how the climate is doing. Now, we have climate models. There's a European climate model. I don't know if your weatherman talks about that, but there's a European, there's a North American, there's a Canadian, there is an Asian, there's all these climate models. And then they give you these things called scatter diagrams. Have you ever noticed those? They have these things called scatter diagrams, which is a whole bunch of the skeeters are being mean this morning. A whole bunch of scatter diagrams that show you how their models are working. Well, when the only way that the models work, we have models that have predicted since 1950s that this climate change was occurring, okay, and the temperature was rising. The only way that those models worked was if you put in the human released CO2, because they are inaccurate if you don't include human released CO2. So those models have for years predicted exactly what's going on in our environment, but without including the CO2 that humans are emitting, they weren't accurate in what was actually happening. So when we look at that, the increase in temperature on the planet, the average increase, like I said, it's gone up to 1.2, and it may even be up to 1.5 by now, because I've only got since 2023's BACS research, okay? 2024, there'll be a lot more research, and I haven't had time to look at all that. But since 2023, it's all been pretty consistent. And the timeline for this rise in temperature perfectly matches the onset of the Industrial Revolution. Greenhouse gas emissions perfectly match. If you plot it statistically, there's something called a statistical model. If you plot it statistically and there's a correlation of 1 is a perfect 100% correlation, okay? 0.97 is the correlation with CO2 emissions during the Industrial Revolution to the actual temperatures that we're seeing today. One of the main things that we see in this climate change, global warming, whatever you want to call it. Everybody's jumped on it because they called it global warming to begin with, but that's what's actually happening. So they started calling it climate change, thinking it would be different, but there are so many people that would tell you that it's not happening and it's not caused by us, that it's a natural cycle. There is no natural cycle that has caused the earth to warm so quickly. Now, one of the big things is, remember, greenhouse gases come in, greenhouse gases get in the atmosphere, and they catch light as it hits the earth and is reflected back off, bounces back off the earth. And that light either escapes or gets caught up in the atmosphere. Now, in the daytime, you could see how if the warming was just in the daytime, you could see how it was not a global phenomenon, but just a localized heat phenomenon, like in your greenhouse. At night, your greenhouse comes down to the ambient temperature around it, okay? But the earth right now, the average night temperature has also risen 1.2 degrees. Okay, the average night temperature has also risen 1.2 degrees. The average winter temperature has risen 1.2 degrees, and it's rising faster in the Arctic than it is here in the lower 48. The temperature change is rising faster in the Arctic than it is here because why? Because the sun shines in the Arctic longer. Does that make sense? Okay. The warming is global. It's not just the United States. It's not just the land. Even the water is warming faster than it should be for a natural change. These are the patterns that scientists predicted all the way back into the 50s that would be caused from CO2 global warming, caused by us. How do we know that how much CO2 we've emitted? Well, it's real easy. We know how much CO2 is emitted when you burn a pound of coal, okay? Or a kilogram, whichever way you're measuring it. And businesses keep close records of how much coal they're burning. We know how much coal we burn for electricity. We know how much natural gas we burn for electricity. We know how much oil was produced worldwide. Because all the oil produced worldwide is all used. Okay, it's not just sitting somewhere, it's used. So we know how much CO2 we've emitted. We know how much we've deforested. We know how many acres, how many hectares of trees and other things that we have removed. And planting trees won't get us out of this. That's a whole nother video. But planting trees won't get us out of this. We're going to have to figure out a way not to emit so much carbon. Now, all of these emissions, you can add them up and take the amount of carbon in the atmosphere, CO2 in the atmosphere, back in 1900, which we can find out by drilling a core sample into ice in the Arctic, because carbon dioxide becomes global, okay? It pretty much equals out around the globe after it's emitted. Us emitting carbon dioxide doesn't mean that Alaska doesn't receive that carbon dioxide. It also doesn't mean that Siberia doesn't receive. They receive that same carbon dioxide that we emitted, okay? It spreads out over the world. It's called diffusion. It diffuses all through the atmosphere. So when we look at ice cores from 1800 or 1900, then we can see exactly, by sampling the air trapped in the ice cores, we can see exactly how much CO2 was in the atmosphere during that time. So we know how much atmospheric carbon dioxide was there, and we know how much atmospheric carbon dioxide released, and when we test the air now, that percentage matches perfectly. Now, we have all kinds of folks in the scientific community that they disagree. And things happen. You know, people disagree. And they disagree because of this reason, or they disagree because of that reason. They find something to disagree about. The reason they disagree is because all science is tested over and over and over. It's our scientific responsibility to test the science that we do. So that's why we publish papers. That's why it's important for our scientists to publish papers. That way I can look at their paper and I can do an experiment to see if I can duplicate their results. Okay? The results have to be duplicable, or else that paper is disregarded. That's the way science works. And science changes. For example, I'll give you an example. Me. The mosquitoes are getting bad. I'm going to fasten my collar. Me, for example. During the pandemic, I put a thing on Facebook that your mask that you wore, that paper mask, only filtered out down to this size. And that a virus was this size. So wearing that paper mask was useless. That was my consideration at the beginning of the pandemic. Now, during the pandemic, they discovered that the virus was actually transferred through water droplets. All right? Little water droplets that come out of your nose and out of your mouth, and it can transfer. The real thing the mask was doing was capturing the water droplets that would transfer the virus. Okay? It wasn't just the virus floating free, it was the water droplets when you sneeze and when you cough, and those can hang in the air for a long time, and the mask reduced that by like 92%. I went on my Facebook page, explained that, and told them I'd changed my mind. Put your mask on. Okay? Science works when you see the science, you reproduce it, and then you change your opinion based on the science. Science didn't lie to you, it just learned more. Okay? Science didn't lie to you, it just learned more. Right now, 97% of climate scientists agree that human-made climate change is occurring. All right? Human-induced climate change, global warming, is occurring from CO2 and methane emissions. All right? We're causing it. It's just the organizations, NASA, NOAA, the IPP, WMO, the National Academy of Science, all agree that conclusion is correct. And remember, every apocalyptic movie you ever watched started off with a scientist telling a politician something was wrong, and the politician didn't listen. Now, we have been tracking solar cycles since the beginning of time, basically. Stonehenge itself was a calendar that lets you figure out when the summer solstice was and when the winter solstice was. Humans have been tracking solar activity for a long, long, long time. Okay? Even if you don't agree that man-made climate change is happening, you have to agree that climate change is happening. Let's take an example. When I was a kid, I live in Zone 6, USDA Zone 6, here in the United States. And when I was a kid, May the 4th was the last frost date. Okay? May the 4th was the last frost date. Now, the last frost date for my Zone 6 is April 15th. Then, when I was a kid, October the 1st was the first frost date, okay, or October the 14th, was the first frost date. And now it's November the 1st. Even the USDA recognizes that the climate has changed that much. Okay? Even the USDA and farmers have recognized that the climate has changed that much. When you look at all of the natural sources, volcanoes, solar cycles, orbital changes in the earth, all those things, they can't explain the rapid warming that we've seen over the last 100 years. Okay, they do not explain it. As a matter of fact, solar activity is probably lower than it's been in 50 years. Solar activity has been declining for the last 50 years. So the climate change that's occurring is happening even with solar activity declining. Okay, in conclusion, human-made climate change is real. Preppers, homesteaders need to be aware of that. Now, will it make a lot of difference in my lifetime? I'm 62 years old. I can't imagine that it's going to make a whole lot of difference. Now, we could see something like as the permafrost melts, it could release large amounts of CO2 or large amounts of methane. Methane is a very powerful, even more powerful than CO2 greenhouse gas. So it could release large amounts of methane. There's methane at the bottom of the ocean. If the ocean warms enough, that methane could be released all at once. Okay? So those could be things that could happen and cause the climate to accelerate even more. Okay? Are we going to do anything about it? Well, there have been 2 or 3 climate initiatives that we have tried on the worldwide stage. Not just America. Other countries recognize this as a threat. It's a national security threat. All right? It's a national security threat. We can't hide from it. So we have noticed it. Whether our politicians will tell us that or not, they're not going to, because somebody's paying for their campaigns. When a campaign for senator in a little state like Kentucky costs $100 million, something is wrong. Okay? Somebody's paying for that because they have an agenda. And that's happening around the world. It's not just the United States. The world is not really trying. We've had initiatives. I think the last, not just this last Paris Agreement, which we pulled out of, but the agreement before that, in 2010, we made an agreement, and there were 20 initiatives that we wanted to accomplish. None of them were met by any country. Let me say that again. None of them were met by any country. So, what's it going to be like in 100 years? I have no idea. It could be that global warming is very accelerated and the planet warms warmer than it's ever been. Okay? That could happen. There could be a whole lot of things happen. We might get hit with a meteor. We might get hit with a nuclear war that puts up enough dust that clouds out the sun so that our planet cools. Okay? There may be a whole lot of things that happen. But right now, for the foreseeable future, the climate is headed up, up, up. And if we don't do something, we're headed for 5 degrees of sea rise. That will melt the polar ice caps, and sea rise will be 4, 5, 6, 10 feet, maybe 2 or 3 meters. Okay? There are parts of Florida that are only 3 feet above sea level. Matter of fact, most of Florida is only about 3 feet above sea level. So it will change the way our environment looks. You know, preppers need to be prepared for that. Homesteaders need to be prepared for that. You may have to start putting covers on your crops. You might have to make it so that you can grow crops in the cooler season and not so much in the heat. But climate change is coming. It's coming. It's barreling right at you. So you got to get ready for it. Now, if you like this stuff, this homesteading, do-it-yourself kind of thing, be certain to come on out to the channel and subscribe. We do this homesteading stuff every week, sometimes 1, sometimes 5 videos. Just depends on what's going on in the homestead that week. If you hit the little bell, it'll be right up here when you come to the channel. It'll notify you when we upload a video. We upload on Sundays, Tuesdays, and Thursdays with the occasional short on Friday and Saturday and through the week. Now, time for me to get on to the next thing. I love you all.